Welcome to Scaling Up H2O, where we are celebrating Cooling Wednesday. Happy Industrial Water Week, everybody. Trace Blackmore here. And as you can tell, we are smack dab in the middle of celebrating Industrial Water Week. Folks, it's Hump Day, and Hump Day Wednesday is where we celebrate cooling. Now, on Monday, I asked you to stand in front of your favorite water softener and take a picture of yourself. Yesterday, I asked you to stand in front of your favorite boiler and take a picture of yourself. Well, today, find your favorite cooling tower, take a picture of that. All those things, please make sure you hashtag all of your posts with IWW21 and Scaling Up H2O. That's how we can all celebrate together and just blow this holiday out of the water. See what I did there? Nation, today is all about cooling. And I'm not sure why this is, but I've always gravitated more towards cooling than any other aspect of water treatment. Now, don't get me wrong. I understand a bunch of areas of water treatment. I don't think I'll ever master any of them, but I am a student of all of them. But there's just something about cooling that I just connected with. I don't know if that's what my father taught me first, if I saw a cooling tower before I saw a boiler. I don't know why that is, but it is that way. I'm curious, do you have a certain part of water treatment that you gravitate more to? Yesterday, I told you a little bit about the history of the boiler. Well, today we're going to talk about the history of air conditioning. Now, the invention of the air conditioner is credited to Willis Carrier. You heard that name before? He invented that back in 1902, and his goal was to control humidity in a printing plant. Humidity was giving them problems, and he wanted to remove that humidity. In 1933, Carrier Air Conditioning Company of America developed a belt-driven condensing unit that became the model for the modern air conditioning systems that we have today. Folks, I tell you every Industrial Water Week and pretty much every episode how much I love our industry. But I get the privilege to treat the oldest chiller in the Atlanta area. It was made in the 40s. It's still going strong today. And our products are proudly running through that chiller. History is so cool. Being able to be part of history and treating something that's so old is just such a privilege. And when you think of all the inventions that had to happen in order for us to do what we do today, it is just so humbling. And the thing about history, the more you know about it, the more you can appreciate everything around you. And speaking of history, today we're going back in the archives again to episode 161. Now, that episode aired back on October 7th, 2020, and you might remember that I tried to stump you with some Jeopardy questions. Well, here they are. Let's see if you can get all of them right. So here is our Wednesday installment of Industrial Water Treatment Jeopardy. This measurement will raise 1 pound of water 1 degree Fahrenheit in 1 hour. What is the British Thermal Unit, or BTU? The metric equivalent of that is the calorie. The difference between the entering hot water and leaving cold water in a cooling tower is called this. What is the cooling tower range? A chiller ton is how many BTUs? What is 12,000 BTUs? A chiller ton is 12,000 BTUs, where a tower ton is 15,000 BTUs. They add an extra 3,000 BTUs for the parasitic heat that the chiller makes. Water droplets that are lost to the exhaust air are called this. What is drift? And our last question for Wednesday's Water Treatment Jeopardy: in terms of the heat transfer coefficient, the term U is defined by this. What is heat change across the heat exchanger in BTUs per hour? Without a doubt, one of our favorite things that we do on Industrial Water Week, at least we started last year, was we listened to a new episode of Detective H2O. Well, James, the world is waiting for the next new episode, but while we're waiting, we're going to replay the Detective H2O series that we played last year for Cooling Wednesday.
Welcome to Detective H2O, the case of misdiagnosis. The birds chirped cheerily as the sun shone brightly through the streaked office windows of Herbert Henry Oxidane, P.I., CWT. Detective H2O squinted out the window uncomfortably. I don't like it. Everything is so bright, it's hard to see what's going on out there. I'll take a good drizzle any day of the week. The first clap of thunder and the black mid-20th century phone both announced themselves at the same time. On the third ring, the water detective answered the phone. Detective H2O here, the best water treater this side of the Ohio, solving water problems drop by drop. What you got?
Mr. Oxidane, this is Misty from Widgets BS. You might not remember me, but we met a year ago when you inspected our water tube boilers.
Detective H2O remembered Misty all right. He couldn't forget the sweet smell of lemon verbena perfume. He had worked shoulder to shoulder with her as they climbed through 3 water tube boilers during the summer plant shutdown. Yes, I remember you. Inspection, water tube boilers. You passed. Your boilers passed with flying colors.
Yes, that was us. We need you again, but this time for our cooling towers. We're having problems with our microbiological control feed program. Something is not up to snuff about it, but we don't know what. Can you fit us into your busy schedule, Mr. Oxidane?
Let me check my calendar, said Detective H2O as he ran his finger down the empty page. Yes, I happen to have an opening this morning. I'll be there within the hour. Will that work?
Of course, Mr. Oxidane. I look forward to seeing you in an hour.
Detective H2O cracked a crooked smile as the rain started during his drive to Widgets BS in his old Ford. He was looking forward to this visit. Making his way beyond the guard shack, he headed straight to the powerhouse. Misty Downs was just inside the door, silhouetted by a burst of steam from a recent boiler blowdown to the drain. Arms on her hips as she walked towards him, she exclaimed,
Mr. Oxidane, I'm so happy you're here. Follow me.
Putting up no resistance, the water detective gladly obeyed. When they reached the water testing station, Misty said,
Look at this, Mr. Oxidane. The free chlorine levels have taken a dive, right out of the blue. All of a sudden for the last 3 shifts. We don't know what's going on. We've turned up the bleach pumps, but no luck. Now, I'm smart enough to know there are 2 sides to the oxidation coin. One side is demand. The other side is residual. You can't have a free chlorine residual until you've met demand. We've been racking our brains, see? Is there process contamination? Perhaps oil leaking into the system, causing an increased demand. I guess on the flip side, are those little microbiological critters multiplying at such a rate that we just can't keep up with demand? We just don't know, Mr. Oxidane. We just don't know.
The water detective scratched his chin as he thought. Let's take this one step at a time, Misty. What you say is correct, but let's start from the beginning. Can you give me a sample of the cooling tower water? We need to run some tests.
Sure,
replied Misty. A moment later, she was back with sample in hand. Detective H2O started his barrage of testing, beginning with the free chlorine test. It was completely colorless, but his sharp, well-trained eye did catch something immediately. He moved on to the rest of the testing, including total hardness, total alkalinity, conductivity, pH, and tracer. This is interesting. Can you take me to the sodium hypochlorite feed station and cooling tower basin, please?
Of course. Have you found something, Mr. Oxidane?
Maybe. When they arrived at the sodium hypochlorite feed station, the water detective noted the pulsing of the dosage pump in its tubing. With the flooded section, priming did not appear to be an issue at this point. The pump was pumping to beat the band. Moving on to the cooling tower, he noted a fine white foam covering parts of the sump's water surface. Some of it got caught up and flew out the top fan as he took a peek inside the cooling tower plenum area. Detective H2O then led Misty back to the sodium hypochlorite feed pump, which he swiftly turned off. With her mouth open, Misty asked,
Why did you do that? We don't even have a free chlorine residual, and you're turning it off? Don't we need more bleach instead of less?
The water detective took a moment to enjoy the perplexed look on Misty's face before revealing his hand, a full house. A little crease formed between her eyes when she was perplexed. You do have a good understanding of the basics of oxidizing biocides, Misty, but I believe you were blinded by the light on this one. Let me show you. The water detective led her back to the water testing station, poured the cooling tower water sample into a sample vial, and said, Now watch what happens when I place the free chlorine test reagent powder into the sample.
It's just clear, Mr. Oxidane. That means no free chlorine.
No, watch again, said Detective H2O as he rinsed and reported the sample. Come closer. Watch the very beginning, right when the reagent first touches the water sample. As Misty and Detective H2O stood cheek to cheek watching the free chlorine test reagent powder pillow drop into the water sample, it happened. Did you see that, Misty?
Yes, I did. What does it mean?
That flash of pink you saw as the free chlorine test reagent powder hits the water proves there actually is a free chlorine residual in your cooling tower.
What? Why? How?
Did you notice the other test I ran before? Did you notice the colors some of them changed? The total alkalinity test, for instance.
Yes. I did notice that one test in particular turned different colors than normal. Instead of a green and reddish transition, the colors were blue and yellow. I just figured you were using a test I hadn't seen before.
No, Misty. It's the same total alkalinity reagents most every other water treater uses. Did you notice the white foam on top of the cooling tower when we took our look inside the plenum area?
Yes. I thought it was from whatever the contamination is. What's going on here, Mr. Oxidane?
Regretfully bringing his consulting services to a near close, Detective H2O finally revealed his complete hand. It's quite simple, actually. You're overfeeding your sodium hypochlorite. When this happens, it can bleach out the water analysis tests, giving suspect or erroneous results. The free chlorine levels are so high that they are bleaching out the free chlorine test almost immediately. But when you watch closely as the test reagent powder hits the water, you can see a flash of pink. That's the reagent doing its job just before it fades from the high sodium hypochlorite levels. Also, the total alkalinity test turned blue and yellow because of the sodium hypochlorite overfeed. The tracer test was affected as well, so I suspect you may be overfeeding your inhibitor product too. Lastly, that white foam we saw in the cooling tower water was, once again, from the sodium hypochlorite overfeed. That's why I turned off the oxidizing biocide pump. Seeing her disbelieving look, the water detective took the cooling tower water sample, prepared a dilution, and ran the free chlorine test again. A beautiful pink color bloomed in the sample. See, once we properly dilute the sample, the free chlorine residual is clear as day. Smiling broadly, Misty gave the water detective a big hug.
Thank you, Mr. Oxidane. Or should I say Detective H2O. You saved the day.
For once, the water detective was speechless as his face turned the rosy pink of a free chlorine test. In the underbelly and penthouses of the metropolis of Waterville, where the boilers percolate and cooling towers fog, there is one man who works tirelessly to end corrosion, stop scale, fight low-life microbes, and conserve water. That man is Detective H2O, best water treater this side of the Ohio, solving water problems drop by drop.
Nation, I know you love Detective H2O as much as I do, and we all thank James McDonald for that. And another thing that we can thank James McDonald for is the James's mini challenges that we are doing all week long. Of course, every single week we do a James's challenge, and those are 52 opportunities for us to be 1/52nd better than we were the previous week, and to just think outside of the box of things that we normally do. So again, we did not shrink James, so the mini James's challenge is not referring to the size of James, but the size of the challenge. So here is regular size James in today's mini James's challenge.
Hello, Scaling Up Nation, and happy Industrial Water Week. Today's Cooling Wednesday James's mini challenge is post a picture from inside a cooling tower's plenum area, looking up. Following all safety protocols, of course, but grab a shot inside the cooling tower, looking up. People see the outside of cooling towers all the time, even if they don't know what they're looking at. But not as many see inside the cooling tower. Let's show them. Most of all, be sure to share your pictures on LinkedIn and other social media by tagging it with hashtag IWW21 and hashtag ScalingUpH2O. This is James McDonald, and I look forward to seeing what you share.
Nation, I was recently at a training seminar, and someone came up to me and told me how much episode 108 meant to them. That episode originally aired on October 19th, 2019, and this is where a listener called in and asked about all the different ways that we could feed cooling tower product using a controller. This is a great episode for someone who's just starting out, but it's also a great episode for somebody who has been in the industry for some time, and they need to explain feed to a customer, and they haven't had that frame of reference in a very long time. The way I really prefer feeding cooling towers is based on demand. And there's two ways to do that. There's how much water is coming into the system, and that is my favorite way to do that. If we lose water for any reason, our controller is going to know about it, and then it is going to pump the proper amount of product to replenish whatever was lost. So that means if we have a leak, if we're bleeding the system, however we lose water, we're going to see it via our controller, and the right amount of our inhibitor is going into the system. Now, if we're just using bleed and feed, well, let's say we have a leak in the cooling tower. That controller is never going to see concentrated up water because we're never concentrating the water up because of that leak. So it's possible we never feed product into that cooling tower. So water meters are one of my favorite ways to feed product. And water meters are just a great thing to have on a cooling tower. A lot of municipalities are giving credits for the amount of water that's being evaporated, which is about 90% of all the water that comes into the cooling tower, versus going down the drain. Now, here in Atlanta, we have very old infrastructure, and it costs more to get rid of the water that you bought than it did to buy it. So it really makes sense to take advantage of that credit. So we have water meters on the incoming water on the makeup, and we have meters on the bleed. Our customers then record those numbers, and they're able to get a credit. So check out if your municipality will allow that to happen, because I got to tell you, if you are talking to a customer and they don't know about that, and you now tell them that they can save this money, it is way more money than you could ever charge them for your water treatment program. So that is something you definitely want to check out. And the only way you can do that is with water meters. So a water meter that you would buy would have some sort of contactor in it. And after so many gallons, it sends a pulse back to the controller, and the controller is then set up via you to know every time it gets a pulse, it's 10 gallons or 50 gallons or 100 gallons. And now you've done your math, and you said for every so many gallons, we're going to energize the pump relay to come on for a specific amount of time, and that's going to precisely treat all that new water that came in. So that is feeding based on demand, and that's one of my favorite ways to do that. Back in May of 2020, one of our friends from Evapco, Brett Alexander, stopped by to help the Scaling Up Nation know more about the cooling tower. Now, one of the items that he taught us is that not everything we think is a cooling tower is actually a cooling tower. If you need a refresher on that, listen to episodes 137 and 138. Brett tells you everything about the cooling tower. Now, here's something Brett taught us about the cooling tower from episode 138. I'm sure you're going to enjoy.
Everybody's familiar with the open cooling tower setup, right? The large water volume connected usually a plated frame, heat exchanger, or a chiller. So we mentioned last week about the closed circuit coolers and the evaporative condensers with the coils. So I just wanted to touch on a couple things to keep in mind when treating those units. Typically, those units, when they're outside, you'll see them with a spray pump right by the unit. And then it is connected to a piping that goes up the side of the unit. That's called a riser pipe. That's what transports the water out of the basin up to the top of the unit and then sprays it over the coil. So what we see a lot is people trying to tap off that riser pipe to bring supply water to a conductivity manifold or a supply line to then inject some chemicals into it. I just want to give you a heads up that those riser pipes usually are very low pressure. So you might be only having 2 to 6 PSI of pressure when you are tapping off of that. So depending on how far you're trying to bring that supply water to your water treatment setup, you might have issues getting it back into the basin of the unit. So you might require like a booster pump depending on the size of the run. So just keep in mind the low pressure of that riser pipe on closed circuit coolers and evaporative condensers.
Nation, I think you will agree on this comment. Every cooling tower should have filtration. They should come that way. But I know it's more expensive to do that. And so many customers value engineer filtration off of their cooling towers, and then they just want us to deal with it. Well, folks, if all this crud is in the system and there's this huge barrier of gunk at the bottom of the cooling tower basin, how are we possibly going to treat it? And of course, it doesn't just stay in the cooling tower basin, it goes everywhere. It's my hope that someday every single cooling tower has filtration on it so we can get all this debris out of it. And trust me, we can do our jobs a lot better when all that debris is absent. Friend of show Bryan Hayward joined us back on August 2nd, 2019 to tell us all about filtration in episode 97.
The basic concept with cooling towers, I think, as we all know, is that they pass water across air, large volumes of air, and it allows the water to evaporate and cool the water from 95 degrees to 85 degrees or so. So we have to put a lot of air through water. Usually, most often, contamination in cooling water systems comes from the particles that are washed out of the air. So any cooling tower is continually washing dirt out of the air. And it depends on what environment you're in, how bad that deposition can be. And it also depends on a lot of things like cycles of concentration that you maintain and things like that. But generally, a cooling tower needs to have a filter to pull out particulate in there.
I mentioned earlier this week that I just love going back and listening to those previous episodes and thinking about all the wonderful guests that we've had on this show. I hear all the time that members of the Scaling Up Nation re-listen to episodes all the time. In fact, some companies have certain episodes that they make new hires listen to so they can ask better questions when they take them out in the field. I absolutely love that. And that's one of the reasons that our sponsors love to sponsor this show, because they know the members of the Scaling Up Nation will listen to these episodes over and over again, which also means you'll listen to their promotions over and over again. Now, 4 years plus when I started this show, I had no idea that this show would be as popular as it is. I had no idea that you would want to re-listen to these episodes, and I had no idea that companies would make these episodes part of their training curriculum. I am so humbled by that. And with all of that, with getting to meet all of these people that I wouldn't have the opportunity to meet if I didn't have this show, I have truly enjoyed putting this show together, and it has become a passion of mine. And it's so funny because 5 years ago, I don't even think I knew what a podcast was. It has become one of my passions. I love doing these episodes. I love talking with you, the Scaling Up Nation, and I love celebrating Industrial Water Week with all of you. Today is Hump Day, folks. How are you going to celebrate Industrial Water Week, Cooling Day? And I will talk with you tomorrow where we're going to celebrate wastewater. Have a great Wednesday, folks. Scaling Up Nation, I, over the last couple of days, have just been talking about the Rising Tide Mastermind just from my heart without any script, just telling you some things that I think you should know about what the Rising Tide Mastermind is. First, if you're curious about it, go to scalinguph2o.com/mastermind. But here's what it is. It's people coming together. It's people creating relationships. It's people helping each other get better. As I told you in an earlier episode, I was the one that brought these people together. I created the Rising Tide Mastermind, but what it has become is a community of fantastic people that we all enjoy being together. A couple of weeks ago, we had our first live event. And I have to tell you, it was one of the highlights of my life. And I really enjoyed all the things we did there and just being with that group of people. One of the most fantastic things that comes out of the Rising Tide Mastermind is when we have an issue, most likely somebody else has that same issue. We don't have to suffer that by ourselves. And we don't have to trial and error by ourselves. We can take lessons, what other people did. They'll say, by all means, don't do this because this will be the result. Why don't you try this and you'll get there a lot quicker than when I did it on my first time. Folks, how valuable is that? And I know if we can grow the Rising Tide Mastermind, there is not an issue out there that somebody hasn't experienced that can share with somebody else that they don't have to stumble through. If this sounds like something you want to be a part of, I'd love to talk to you. Go to scalinguph2o.com/mastermind.